friends, in our last session we were discussing about very interesting prescriptive analytics tool, that is decision tree, and we discussed that how if you are having some kind of a situation, alternatives, and you have to take decision that which alternative is the best alternative. So, in that case decision tree is also a possible solution. Similarly, in many situations you are unable to think all possible outcomes and you may not have enough faith on your historical data, and it is very difficult to create any kind of mathematical model for them. In that case, another very interesting tool which we are going to discuss in this particular class, that is simulation activities, can also be used for getting some kind of decision. So, we will first take the problem which we were discussing in our last class about decision tree. You may recall that we had the decision tree which is coming like this, which is there in the previous class also. We had 2-3 options. If you recall, we have the options of all stock market, or we have option of building some capacity, let us say captive capacity, plus remaining from spot market. If you recall, we were discussing that how spot market calculations were done in our previous class, and I gave you a task that I am planning to keep a captive capacity of 500 for 500 units, and remaining X will come from my spot market. If I have requirement of 600, like in these cases, so 500 will come from my captive and remaining 100 will come from my spot market. In these cases where your demand is going 720, 500 will come from your captive capacity and 220 will come from spot market. But downside is that if my demand is just 320 or 480, in these scenarios I may not be able to use entire captive capacity. It will still be with me, but there will be underutilization of 20 units or 180 units as the case may be, because I have less demand and my captive capacity is more than that. So, we need to see which option is better, and for that purpose we were planning to have a decision tree. How did we do the calculation? We discussed the concept of expected profit. For this was our time T naught, this was time T1 and this was our time T2. So, we calculated expected profit for T2 first, and then we calculated present value of expected profit for T1 plus expected profit for T1. That become the total profit of T1, and similarly we did the backward calculation for T naught also, and there may be some initial investment and then NPV of all cash flows at the beginning. So, initial investment and NPV of all these are the two things. The difference of that will give you estimation of profit or loss for a particular option. So, that calculation we have completed for the spot market, in our last class. Now, as I say that we have considered a situation of captive capacity of 500 and the remaining capacity coming from the spot market. I have given you this task, but for helping you now, we are actually coming with this ready-made calculation. And here, though you see that only 9 unique combinations of demand and prices are there. This is demand, this is price. So, only 9 unique combinations are there in T2, but for the purpose of calculation of present value and net present value, we have done that each of these node are emanating 4 different branches, branch 1, branch 2, branch 3, branch 4. It is a different matter that most of these branches are leading to common impact. So, now we are going to have this calculation to show you that how we are going to proceed with this option number 2, where we are keeping the capacity captive capacity of 500 and additional requirement will come from the spot market. So, like you see, in case when it is 720, 500 will come from the captive capacity and remaining 220 will come from the spot market. And though we have 9 unique combinations of demand and price, but you see that for the sake of our calculations, we have divided this table into 16 groups. A group is of 4 items like this. So, that if you see, this is let us say node 1, node 2, node 3 and node 4. So, these calculations are coming for node 1, this is for node 2, this is for node 3, because you may remember, like we have to calculate the present value of future cash flows, present value of future cash flows. So, for calculating the total expected profit in year 1 at node 1, I require the total expected profit from year 2 from all the possibilities and then their present value for node 1 of year 1. You will understand all these things in a minute's time. Now, if I see the first part of this table, out of 720, 500 coming from the available capacity, 220 coming from the spot market. The spot market price is 4.32. The revenue, if you remember, is coming at the rate of 4 sale price. So, that is the demand is 720, this is 720 multiplied by 4. So, that is 2880 and the cost is coming because of this 220 units will use the spot market which is available to you at 4.32. Now, in all those situations where your demand is less, like here 480, there is no need of spot markets. So, therefore, if these spot markets are 0, the cost will also be 0. You can check the entire table. Only when there is a requirement in the spot market, there will be a cost term. The revenue is coming because of 2880, 480 multiplied by 4 and so on, this entire column is coming. The profit is revenue minus cost, revenue minus cost, revenue minus cost, revenue minus cost, that is the profit. Now, for getting this, this is the expected profit, and this expected profit 2004 is basically 29.6 multiplied by the appropriate probability, that is 0.25, and similarly for all these the probability is same So, you can actually do the sigma of this multiply by this to the 0.25, your expected profit is coming to be 2004. Now, this expected profit of 2004 is coming in year 2, in year 2. To calculate its present value, we have to present value of year 2 profit in year 1 will be 2004 divided by 1 plus k, that is the discount rate, and this k is 10%, we remember. So, this 2004 divided by 1.1 comes out to be 1821.82 around. And similarly, for this also, if the same way you will calculate for all these, it will be the present value in year 1 will be 1650.91. Its present value will go to 1454 point something, and this is also 1454. So, as we have seen that these are the expected profits which we will be using for calculation at our year number 1. Now, for year number 1, we have this table where we have taken these profits using their present values. If I try to summarize how are we proceeding, here T2, then T1 and then T0. So, every year has some profit coming on that, we are using its present value plus local profit, you can say, and then its present value plus local profit. Local means the profit for that particular period only. And in this order, for year 1 when I am calculating, these are the demands which are available to us from this demand tree, and the capacities which I will be using from the spot market are 100 and 100 whenever the demands are going 600. The spot market price will be like this. So, you have 100 into 3.6 and 100 into 2.4 as the cost for these two situations. Revenue will come from the total demand and the selling price is 4 rupees, like this. So, your profit will be 2400 minus 360 and so on, and this table is coming, this particular column is coming from our previous calculation, and this is the sigma of 2040 and 1821. Now, the expected profit in year 1 is basically the sigma of profit multiplied by, rather it is not appropriate to say sigma, because each of these demand possibilities and the price possibility have the probability, all these combinations are having probability of 25%. So, we actually are going to, for expected profit, we are going to multiply probability column with the profit column, final profit column, this column. Incidentally, all the probabilities are of equal nature. So, you can summarize it as 0.25 into sigma of profit 1-2, and that comes out to be 3445. Since we have done this calculation in Excel, so there are some digits after decimal also, but for the sake of our convenience we can very easily ignore these points after the decimals. Now, let us go to this particular node T naught, where for period 0, because we are talking of 3 period scenario T naught, T 1 and T 2, and there can be a captive capacity decision also, and we have done a lease agreement for the captive capacity, that okay, in the beginning of this particular process I am shaking hand with you for a price of 2 rupees and 500 capacity. So, for 1 year this is per year. So, for 1 year the cost is coming 1000 rupees, and for 3 years the cost will come at 3000 rupees. The revenue, the demand in the first year is 500. So, 500 into 4, the revenue will come to be 2000. So, my revenue is less and I am incurring more cost in the beginning. So, my profit is 2000, that is the revenue, minus the cost is minus 1000, and whatever discounted profit I am coming from period 1, that is the expected profits present value, and present value of expected profit of year 1, that will come out to be 3445 divided by 1 plus 0.1, and that is around 3132. So, the expected net profit will be 3132 minus 1000, that is my expected net profit, 2132, around that. And if you can recall our previous class, the expected net profit when we are going to buy all the units from the spot market was 1367. So, you can very conveniently make a decision that it is better to have a deal where you are having a lease agreement of captive capacity for 3 years rather going for spot market purchase every year, because here the profit was 1367, here it is 2132. And more scenarios may give you better opportunity that okay, we have done this calculation with 500 as a lease agreement and remaining from the market. You can try, and that will make slightly more complex calculation where you take a decision of captive capacity. You can say this is a homework. Captive capacity of 400 rest from spot market, and you can see that please check what will be the net expected profit, and that will give you more idea about the calculation process also and better decision making. After completing this decision tree example, then another very popular approach is simulation. I hope most of us are aware what do we mean by simulation, and there are different types of simulations which are possible. In this particular class, I will be focusing on Monte Carlo simulation, which is very commonly used across the problems for decision making. Inventory problems can be handled with Monte Carlo, service problems can also be handled. If you go to operation research, queuing problems can also be handled with the help of this Monte Carlo system. So, there are wide variety of uses of Monte Carlo system, where we are going to use a particular kind of a system where every new incidence, every new event is happening in a random manner. One customer is coming, after how much difference another customer will come, I do not have any idea. Generally, when you see in a petrol pump, maybe for 15 minutes there is no customer, but all of a sudden 3 customers come, and this is purely a random behavior. So, trying to model that random behavior is our Monte Carlo simulation, which is very powerful, very useful, and we will see in this particular session that how this Monte Carlo simulation is possible in variety of situations where you have to done lot of approximation, stochastic models are there, where you are having some idea that how customers are going to come, but it is very difficult to develop a mathematical model for these things. For example, we are creating a situation so that we can explain you the use of and the working of Monte Carlo system. Now, in this particular case, there are three types of demands for a particular product are there, and since we are talking of a small case, I am considering only three levels of demand, 3, 4 and 5. Now, probabilities of these are 20%, 50%, 30%. These probabilities we assign based on our past experience, and in this case, for every type of let us say situation, you have to see that okay, the next event, the next customer will have a demand of 3 units or 4 units and 5 units. We follow a system which is known as system of random numbers, and depending upon, you can take a number of random on 2 digits, 3 digits, 4 digits, how much spread you have, fine spread of probability you have. Like in this case, we have 20%, 50%, 30%, or you can say 0.20, 0.50 and 0.30, and then we are making cumulative probability column also 0.2, 0.7 and 1.00. So, here we are using only 2 digits after the decimal. So, we can have only 2 digit random number in our this particular situation. So, since probability is up to 20, so I need 20 random numbers, any 20 random numbers which are coming for this particular first level. So, these 20 numbers are between 0 to 19. Then 70 is the probability, sorry 50 is the probability of 4. So, I need 50 random numbers for designating the probability of 4, and these 50 numbers are I have taken between 20 to 69, and then 5 is 30 random numbers are required, and these 30 random numbers are coming between 70 to 99. You see, since we do not have practically all the possibilities of randomness, so we have given a particular block of random numbers to a particular level of demand. Theoretically speaking, in the most ideal situation, these 20 random number should also be 20 different numbers. Now, I am considering only up to 0 to 19 a particular block of random number. So, whenever we are going to use Monte Carlo simulation, we actually do not have real random numbers, it is quasi random numbers with which we are going to operate, but that is our practical limitation. Otherwise, it is quite possible that I may have one random number 1 and 79, 89, 50, 3, 4, 19, 20 such random numbers I put under one bin, and that will make my 3, and similarly, but that will take huge amount of time, and practically it is very difficult to do that. So, therefore, we take these kind of bin system where we have a block of random numbers representing a particular level of event. Whether the demand will be 3, 4, 5, these are the events. So, next event will be a demand of 3 or 4 or 5. It is decided on the basis of random number which I can generate either using our simple calculator or from the tables which are available in books for random numbers, using the computers also. So, there are variety of ways through which you can generate the random number. Even you see, when you are throwing your dice, whether 1 will come or 4 will come or 6 will come, that is also a kind of random number, but there you have only 6 random numbers. Now, in this particular case, when we have the theory of this particular Monte Carlo system, we have to run this system of inviting the events in a sequential manner, maybe some number of time, so that the output starts stabilizing. And for that purpose, I will take you to the Excel demonstration, which will help us that how the output stabilizes, and we are deciding what is going to happen with each new random number. So, here we are having a small situation for which we are going to do this problem in the Excel sheet. We have two situations. One is the demand, because it is an inventory problem. So, demand can be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and these are associated probabilities, and the supplier may take either 2 days, 3 days, 4 days or 5 days. In all our inventory models, generally we used to consider fixed lead time, but practically it is not going to be fixed lead time, there may be different lead times. So, the probabilities are 20%, 30%, 35% and 15%. These are some of the costs available for the data available to us. Ordering cost is 80 rupees per order. Holding cost is 2 rupees per unit per day. Generally, you remember the data for holding cost which we used in our previous classes is mostly for per year basis, but here it is per unit per day. The shortage cost, if the order is not fulfilled, if demand is there and you are unable to fulfill, that is 20 rupees per unit. Reorder point is 20 units. Whenever your inventory reduces to 20 units, you place a new order, and the beginning inventory is 30 units, and order quantity every time you place the order, that is Q. Let us see the performance of this particular system, that how you will model this situation. You may find some very interesting outcome with the help of our simulation running. So, we will go to the Excel now. Okay. So, now we are coming to this simulation Excel sheet, and we have generated all the required information which is needed to develop this Monte Carlo simulation. And now, for that purpose, as you remember, there can be different types of demands. So, if I go to the demand table, demand can vary from 3 to 12. These are the probabilities which we already know. We converted these probabilities into the cumulative probabilities, and then you have the random number ranges. These are the random number range. So, in fact, we will be needing these information when we will work on the simulation worksheet. Similarly, for the lead time also 2, 3, 4, 5, these are the possible lead times, and similarly random numbers are generated for different lead times also. Now, going further, for our simulation worksheet, now we have started working on the simulation for this. Day 0, our beginning inventory is 30 units. Beginning inventory is 30 units on day 0, that is given to us in the problem. Day 1, I generate a random number, maybe using my calculator. The first random number, now when you generate a random number, the random number may be very long. For example, first random number which I press in my calculator, now it is showing me that is somewhere around 5, 3, 7, 8, 9 like this. Now, depending upon my requirement, I may take 2 digits, 3 digits, 4 digits, anything. So, you can say that random number for me is 5. I am taking first digit of this. Now, when this 5 is there, we can see that the demand is, this 5 is falling in this 2 to 9, 5 is in this range. So, the demand is correspondingly 4 units. So, we go to this and we put demand as 4. and when the demand is 4, you will have 26 units left with you, you will fulfill the demand of 4 units. Now, ordering cost, the holding cost is 2 rupees per unit per day. So, at the end of the first day, you are left with 26 units. So, you will incur a holding cost of 52 rupees at the rate of 26 into 2. Next day, you again generate a random number between 0 to 100. The next random number is 0, and this 0 is corresponding to demand of 3 units. So, 3 is the demand, 26 minus 3, you are left with 23, and then 23 into 2, 46 is your holding cost. You will keep decreasing your inventory till you reach the reorder level of 20. So, we will generate another random number, then this random number is corresponding to demand of 10, and when this correspond to demand of 10, 23 minus 13, 10 becomes 13. 13 is less than 20. So, you have to trigger one order here as per your policy, and order will be of 40 units, that also you know. So, here you need to know after how many days this order will come to you. So, you need to generate one more random number. Now, it is quite possible we have generated separate random numbers for the lead time, but I may work, because it is a random number. So, there is no mistake in that. I may work with this 79 also, I may work with this separate random number I have generated for lead time, that is 91 also. So, if 91 is my number, 91 will fall in 5 days lead time. So, this 5-day lead time means after 5 days I will come. If this would have been 79, if I take this 79 as my lead random number for lead time, this 79 will come under 4 days lead time. So, in that case, after 4 days I will get the supply. Now, since I have accepted 91 as my random number, I will get after 5 days. So, if it is 79, this would have been 4 days. Right now, I am talking with 91, it is 5 days. And so, right now my 13 units are there, and the stock will get replenished after 5 days, where I will get a supply of 40 units. And now, when you have placed the order at this point, you will incur a cost of ordering also, and only 13 units were there. So, cost of holding will be 26. Similarly, next day comes, random number is 60, demand is 8, 13 minus 8, 5 are left. I am running a holding cost of 10 units. Another day comes, I have a demand of 3 units, perfectly fine, I am able to serve. Then on the 6th day, random number comes to be 84, and corresponding demand is 10, and now I have only 2 units available with me. So, I can fulfill the demand of 2, but I will not be able to fulfill the demand of 8. So, in fact, I have a balance of minus 8 here, and for that purpose I will pay a shortage cost of 8 into 20 rupees, 160 rupees. This is my shortage cost I am able to I have to pay on this particular day, because I do not have any item available with me, and I have to pay the shortage cost for this particular item. Then next day comes, here I have another random number of 18, and the corresponding demand is 5. Since I do not have any item, again for this demand of 5, I have to pay a shortage cost of 100 rupees. Now, on day 8th, now I am getting the 5th day after placing my order. The supply of 40 items come to me, but the demand on this particular day is 7. So, immediately 7 items are lost, means sold from this. So, only 33 items are left with me, and in this way continuously I am updating for as many rounds as I want. Like we have done this particular solution, if I go to the bottom of this table for 40 particular days. So, 40 is not a enough number, we can do it for let us say 100 days, 200 days, because this is just to be done on a paper. So, there is no cost associated for running the simulation, and after 80 let us say n number of days, you can calculate that what is your total cost of this particular model. So, total cost may include the cost of holding, ordering plus shortage. So, all these are the different types of cost, sum total of that is my this particular thing. Now, in this case, since the model is there, you can try this simulation model like our decision tree model by changing the policies. Here my reorder point I am considering as 20 units. You see that right now my shortage cost, ordering cost and holding cost. Should I decrease my reorder point maybe from 20 to 15, or should I increase the reorder points from 20 to 30? You can just play this simulation game again and again, and with that new kind of alternative scenarios you will be able to take a decision. So, that is also a good way of getting a decision out of means we have created just one policy in this example, but you can create multiple policies and compare your simulation result that which particular policy is giving me minimum cost of inventory, minimum cost of ordering, holding, shortage, that is a good policy for my system. So, with this I hope you can continue solving this particular problem using your own systems with creating multiple ordering policies, and accordingly you will be able to see which policy is a more suitable policy or giving you the minimum cost of inventory. With this we come to end of this particular session. Thank you very much.